Hi, and welcome to the first video in a series of videos for our data structures class. Just a moment, I'll share my screen and we'll walk through some basic information about the class and about kind of an overview of what data structures are all about. So stand by for one. Okay, that was a long one, but here's the presentation. I'm going to post this presentation up. It's Google Slides. I'm going to post it up in the class after we get this video uploaded. So cop4530c, data structures. I think it's going to be a great class. I know faculty generally say that, but I do really think it'll be a great class. And I am really looking forward to working with each of you because I enjoy teaching the BAS program. I've got some fantastic students and I always enjoy those classes. And I've taught, the seminar a couple times and the capstone once. It's always been good. Now, full disclosure, this is the first time I've taught this data structures class. Because it's the first time anyone in the BAS program has offered this class. It's a brand new class. But together with Dr. Macon and lots of others, I helped design the class because I think it's critically important for our students because understanding about data structures is critical for software development in several different ways. We'll talk about it along the way. So I have a substantial intellectual, maybe emotional investment in this class, and I'm going to work to make it educational and enjoyable. So let's look at what we mean by data structures. That's a really vague term. I mostly mean what Java, your Java class, probably called collections or containers or collection classes. Containers are classes themselves, like think about array list is a good example that you might have used in some of your software development classes. We're focused on how, in this class, on how collections collect, I know collections collect, objects. So a collection is not just one object or one class, it's multiple objects put together in some kind of structure that makes it easy to access or easy to manipulate according to the needs of the particular problem. There are many different data structures and they each has its advantages and disadvantages that we'll talk through. So there's very little inheritance visible here. So maybe you spent a lot of time in your software development classes talking about inheritance classes. But here, it's much more about containment than about classes. So in other words, we're not as interested in a car is a vehicle, as we are interested in those things that a vehicle might contain. So we might have a data structure inside the vehicle object, which is derived from instantiated from the vehicle class. And that would have a list or an array list or some other data structure holding all the parts of the car. So that's the part we're interested in. We're mostly dealing with objects rather than classes here. Now, in Java, everything is a class. So of course, there are containers are container classes. But primarily, we're interested in how these classes can hold data that makes it easier to solve the problem that we need to solve. A lot of classes are probably focused on procedural code, the step-by-step stuff. When you coded loops and you coded ifs and functions, those are all focused on executing an algorithm, or if you don't have an algorithm, maybe a heuristic, approach, step-by-step approach to solving a problem. And probably spend a lot of time on the logic of that. We're going to spend a lot more time in data structures focused on how to represent, how to create a collection, how to store objects in the collection and get them back out again or search for them, and maybe even how to persist that collection onto some secondary medium like disk. So how do we save? We built this big data structure. So we built a tree. How do we get this balanced tree out onto disk so we could use it later on again? We'll talk about a structure called B trees that are really designed with this kind of persistence in mind. we're going to code projects in a variety of languages. So I know folks kind of think, well, I want to specialize in one language. I'll just be a Java programmer. That really doesn't fly in this class or any others, because you'll find as you move out into software development that knowing multiple languages is critical. So you have to know how to code in more than one language, or at least be able to learn really quickly how to pick up another language, because languages are changing all the time, and different programming coding languages are aimed at different kinds of problems. So we're going to actually use Python in this class, because Python has a lot of nice built-in data structures. You don't have to code them yourself. They're already there and they work really well. We're also going to do some Java, because that's what folks are familiar with. And some of the things we're going to do are maybe more obvious in Java than they are in Python, because Python treats a lot of data structures as black boxes, and you don't even know how they're implemented. That's a good thing. And this class is much more about being an intelligent consumer of data structures than being a creator of data structures, but we'll need some Java too. If you know some other language and you want to use that language in there also, God forbid you want to use C, we could probably work that in. It would actually work well, because the more languages we have used by different students to solve a particular problem or implement a particular data structure, or apply, I should say, a particular data structure, the more variety we'll get and the more useful it'll be. So we're going to try to apply data structures, either the ones we build ourselves or the ones that come with the languages, to somewhat realistic problems. Now, we're limited in the problems we solve. We can't have super large data sets or anything like that. But we can look at realistic applications of data structures rather than studying them in the abstract. So what kind of things will we do in class? And I mean, say in class, obviously this is an online class, but as a part of our class, what will we do? Well, we'll use selected chapters in the zybook. We'll talk more about that in a minute, where there's some reading, actually limited reading. There's lots of little self-scored quizzes to take that you can take it over and over again as many times as you want. And there's some exercises, problems, built into the interactive nature of the book. It's an app, of course, it's not really a book, that also help to cement the things you're learning and reading about data structures. This is the first time I've used this particular zybook, but I've used many others. I've used them in C, I've used them in scripting languages, I've used them in C++, I've used them in Java, and they've all been good. And most students really like the interactive approach. And they say when they're asked at the end of the class, but how did you learn these things? A lot of folks say, I learned it from using the zybook. So I think you will find that too. You're going to get to watch more of these amazing videos from the One Take Wonder here. And I'll try to keep them shorter than this one. This one's going to be kind of long. And we'll take a short 3 to 5 item quiz on the videos. So just to make sure you actually watch the video. We'll do coding projects. This is going to be the bulk of our work, I think, to apply some of these data structures to realistic data sets, or at least real world data. And I've got a bunch of data related to, you'll love this, links buses. They're buses, the schedules, the routes. And I think we'll try applying some data structures to finding out, investigating some interesting things about the links bus data. At least it's a down-to-earth problem. Most of what you do for these projects will end up in discussion posts, because a lot of what we're going to do, I want it to be shared across multiple students. I want other students to see your output and you to see their output. So there'll be a lot of posts and replies, more so than there are some things you submit, because sometimes you need the code to be private just to you. But a lot of times we'll be able to do it in discussion forums where everybody can see. I think that's the way it should be as much as possible. There will be a final exam, comprehensive final exam, and that's going to be based on the discussions and projects we do. So I'll go back through the course and look at the projects, look at the discussions, look at the video quizzes, and put together for the final, not comprehensive, but a longer list of questions that really is going to cover directly what we covered in the class. The zybook also has some questions, and I can certainly throw those in too, because they come with pre-made questions, which is easy on me, but maybe not as directly relevant to you as it might be. Let's talk about how to get in touch with me. The best way to get in touch with me is to use Canvas messages. I've got it set up finally. So these go to my cell and they notify me. So they ding, my phone dings, and I can't resist looking to see why the phone dinged. So I will probably be able to give you at least a tentative answer pretty quickly. Now, sometimes that answer is just, gosh, I gotta take a look at this code and I'll get back to you. But sometimes it's something really simple, or you're just asking about something procedural in the class. We can get that covered, in 15 minutes. So round trip. For longer, more complex discussions, you'll probably need to schedule a Zoom meeting with me. Nobody greatly enjoys the Zoom meetings, but I end up doing a lot of them, and they're usually pretty helpful because that's what takes the place of face-to-face interaction in a purely online class. We need to schedule them in advance because I have multiple meetings. I have to work in my schedule, and your schedule usually turns out to be more of a constraint than mine, because this is my only job. So I can usually fit you in, but you may have lots of jobs and family responsibilities and other stuff. And so you need to schedule a Zoom meeting at a time when you can make it, and I'll try to flex and make that. If you have problems with code, you can add screenshots to the messages you send me. That's better than nothing. Oftentimes the screenshots are just tantalizing because the part of the code I really need to see is not in the screenshot, or there's just an error message and no context, but it probably helps. And sometimes I can just look at a screenshot and say, oh yeah, I see the problem. A better way for really tricky problems, ones that you're really stuck on, is to put your code into replit.com, replit.com. That's an online IDE, a cloud-based development environment, which is free to use, and at least in limited quantities. And there, if you put your code in that environment, it's basically, you can put Python code there, you can put Java code there. I can fork it, meaning that's the get speak for make a copy of it, mess with it, test it, maybe some, change a few things, put some comments in it, and point you back to a hopefully better fixed version, and you can take off from there. I found that a very effective technique for a lot of problems in this class that would have taken a long time to explain over Zoom, and would have not been able to be explained at all, probably over messages. You can, of course, email me at the address in the syllabus. I check that a lot, but it doesn't notify me because it would drive me crazy. So I have notifications turned off there. So it's not as quick as Canvas messaging. It's going to be a while probably before time to look at my phone and see if I got any messages, as opposed to the Canvas messages where it goes ding, and I'm immediately aware that somebody wants to talk to me about something. Let's talk a minute about asking questions. I think this is a big stopper, a big concern for students, in my experience. Please don't be reticent, don't be reluctant to ask me for clarification or extra resources or help. That's literally what I am here for. There's no penalty, either in terms of points or in terms of losing face, in asking me questions. I'll try to answer your question, and if your question's, sometimes I will answer part of your question and tell you to figure the rest of it out. If you go back and you can't figure it out, you can ask me again and I'll tell you some more. I want you to learn as much of this as you can on your own, because I think that aids retention of the material, when you work things out on your own. But there's no value in being stuck for hours at a time. That's just frustrating, and you're not learning anything. So when that comes up, let me know and ask me to help you. You can also ask your peer students for help. Particularly in the discussion forums, it's a good place to do this. I don't want to get huge blocks of copy and paste. So I would be very, very disappointed and angry if you turned in someone else's work. Obviously, you know that. But if you asked another student and that person said, I did it this way, and try looking at this web link, and maybe try these 3 lines of code, I would have no problem with that. That's a great thing. because in our classes, always, there's a wide variety of experience from folks who came up with, really maybe no coding experience whatsoever through the AS program. Now you're in the BAS and you know a lot more stuff, but maybe you don't have any experience in the industry. And there will always be a few people in the class, statistically speaking, who already know a lot of the stuff, and they can help you out. And they're often willing to do so. So ask your peers, not necessarily in lieu of asking me, but maybe in addition to asking me. Other students might see the problem more quickly than I do. And I think I want you to understand that. There is a question of plagiarism, but just asking another student for help in terms of how do I do this, or how would you do this, and getting snippets of code in response is perfectly all right. Last but not least, let's have as much fun as we can with this class. In other words, maybe you don't find some of these classes fun. I think you will find this class fun, even though data structures can be a dry and somewhat abstract topic. Because first of all, keep in mind that this is going to be really, really helpful in job interviews that you get and in successful software development work. We've already gotten a lot of feedback from our graduates that they were asked in those interviews, tell me how this particular data structure works. How would you use a tree? Draw a tree on the board, a balanced binary tree. And I think your ability to do that as an intelligent consumer of data structures, even if you don't know all about the detailed pointers and so forth in the implementation, and if you can talk about the advantages and disadvantages, why this particular data structure collection would be a good candidate for this problem versus a bad one, that really, really helps. Also, just to be successful in software development, you need to be able to use data structures. It's not just all strings and arrays. Many, many problems require that you handle a substantial amount of data, collections of data, and data structures let you do that. And I say, maybe some people think this is not true, but I say using the right data structure can make your code 10 times easier, and using the wrong one makes it many times harder. Sometimes when you choose the right data structure, it's pretty obvious what the code needs to be. And if you're struggling and you've got 3 different arrays, each of which has a piece of the data in them, and you're trying to cross-correlate them, maybe you should stop and think about, is there a better data structure I could use that would make this much less tedious? So that's the idea. And I think you will enjoy this class. I'm going to enjoy working with you. And I will be seeing you in other videos and in the discussion forums very soon now.